Blekman. So, if you're wondering what's going on over here, you might be as confused as I am. But what I know is that these two are cavemen. This is Bing, and this is Bomb.
Bomb!
And Bing just got a splinter, which really hurts. So, now they're going a bit crazy.
Big stick? Small stick?
With the pain of the splinter, these two cavemen stumbled on a journey to answer a very important question. What is the universe made of? They were smashing sticks and rocks. For example, Wong just discovered what he thought to be the smallest rock he's ever seen.
Being so fascinated by the fact that things could just get smaller and smaller, they thought that they should name this place, and they came up with the name Geneva. So, if you're wondering what a place close to Geneva looks like today, just wait, because you're about to find out.
Alrighty, hi everyone, my name is Annabelle, I'm from Canada.
And I'm sure I'm from India.
And we're going to take you on a tour today of CERN and the Large Hadron Collider located right here in Geneva, Switzerland.
So, who are you? What do you do here?
Hi, my name is Yejin. I'm an engineer and I'm a master student working on one of the largest machine in the world in CERN. And here it is. I'm currently working on a 100 kilometers accelerator tunnel under Geneva, and we have 4 detection places where collisions happen. The biggest two being CMS and Atlas.
Thank you.
Wow, that was so interesting. And what are you working on over here?
Well, I'm Max, and I'm a computer scientist here at CERN. At CERN, we can see data and 3D images from over 40 million different types of collisions in CERN at the Large Hadron Collider. Obviously, we can't store all that information, so we have to reduce it down to about 10,000 collisions. So, imagine these 10 people here are the 40 million collisions that we have at the Large Hadron Collider. So we obviously can't store all of this data, so we're left with just a shoe. This shoe represents 10,000 collisions out of these 40 million here, and this shoe represents, anomalies, collisions randomly chosen, and collisions we don't even know and identify. We don't know what they mean. So.
Wow, amazing.
Who are you looking for people working on?
Yes, so hi, I'm a Swedish particle physicist, and in particle physics we have this wonderful model called the standard model, which is basically it describes all the elementary particles that we know of, shown here. And elementary particles are basically the tiniest building blocks that we have in the universe. So for example, the quarks here, they make up protons and neutrons, and that together with the electrons build up atoms, and so on and so forth. And all these particles are affected by all the different fundamental forces that we have in the universe. It's really interesting.
Wow, thank you so much. That's really interesting.
It's such an international group of people working here at CERN. It's almost like science for society.
Wow, you're right.
Oh, hi. I'm Mohammed Hablami, and I'm from the UAE. I'm a mathematician at CERN, and what we have done is that we've collected many measurements throughout the years, and we have wanted to decrease the probability of error to less than the probability of winning the lottery. And here, this is a very simple equation that we have perfectly combined particles. So simple.
So you know it, right?
We know that we should have mass, and your model contradicts that.
But Higgs boson doesn't explain why different elementary particles have different masses.
What about the mass antimatter disparity in the universe? The Standard model doesn't account for that.
So you ask about the masses different for every particle, and and that the gravity cannot be unified with the standard model as we know it. Well, these are good questions, but actually we tried doing the math between quantum mechanics and gravity and it just doesn't work out. Maybe, and even we tried to find the graviton, we didn't find it, so we still need higher energies in our accelerators to be answering those questions, but as far as we know, we don't know the answers.
And as for your question about matter and antimatter, it is a valid one. As far as we know, in the creation of the universe, there was an equal proportion of matter and antimatter created, but we also assume that everything around us is made up of matter, so you might be wondering, where did all the antimatter go? Questions like this have been fueling the curiosity of scientists for many years, and probably many to come. However, approaching to the answers helps us understand what the universe and matter around us is made of, which is the ultimate goal of